Okay, finishing this off, number 17. Negative 27 as my base to the 2/3 power. Okay, so the first thing that I'm going to do is I'm going to take this and I'm going to rewrite this problem as a radical. The negative 27 is going to become my radicand. The 3 is going to become my index, and then this radicand is going to be to the power of 2. Okay, now I'm going to do this one a little bit different than I did number 16, and then you could decide which style you like to solve these with. So now at this point I'm going to take my radicand, which is negative 27, and I am going to factor this out. Okay, and when I factor it out, I'm not going to worry about the negative right now. I'm just going to factor the number. So 27 is going to factor into 9 and 3. 3 is prime. 9 becomes 3 and 3. 3's are prime. Okay, so then when my next step is, after I factor, I am going to take my radical and I'm going to expand it. I have an index of 3, and then my expansion becomes 3 times 3 times 3. Okay, but now there's a problem, and I have to have 2 of these. So I have to have another 3 times 3 times 3. Okay, so now, but I have a problem. My radicand has to be negative 27. 3 times 3 times 3 is not negative 27. It's positive 27. So what you can do, and it's a simple trick, you could just change every single one of those numbers into a negative number. And if you think about it, negative 3 times 3 is positive 9. Positive 9 times negative 3 is negative 27. So that gets me my negative 27, which I wanted to have. Okay, and then I have to do the same over here, and the reason why I have to do the same over here is because I have to have 2 of these which are the same. Okay, now my index is 3, so I need 3 identical numbers. You could see I have 3 identical negative 3's. So I'm going to move that negative 3, I move it to the out of the radical. I have another set of identical negative 3's, so I move those out of the radical as well. So outside of the radical, I end up with negative 3 times negative 3, which is equal to 9. And that is my final solution because I have no leftovers on the inside. Okay. Number 18, positive 64 to the negative 1/2 power. Now when we have this, just take a deep breath. You can't have a negative exponent, but as we've talked about, you could easily rewrite this as 1 over positive 64 to the positive 1/2 power. Okay, now I'm going to change this problem and rewrite it as a radical. So the 1 is 1, but the 64 to the 1/2 power as a radical becomes, 64 becomes my radicand, 2 becomes my index, I'm not going to write that, and 1 becomes my exponent for 64, I'm not going to write that. Okay, and now I'm going to take this 64 and I'm going to make a factor tree out of it. Okay, but in this case, I'm not going to make a factor tree. And the reason is because hopefully you recognize that 64 is what we call a perfect square root. Okay, 8 times 8 is perfect. It makes 64. So that means I could simply, and if I recognize 64 as a perfect square root, the square root of 64 becomes 8. And I could avoid having to do the factor tree. So my answer to number 18 is 1/8. Okay, number 19, the last one, I have a negative 125 to the positive 4/3 power. So I'm going to go straight to changing this problem and rewriting it as a radical. Negative 125 becomes my radicand. It's going to have an exponent of 4, and then I'm going to have an index of 3. Okay, so now I'm going to take this negative 125 and I'm going to make a factor tree out of it. And once again, when I make a factor tree out of it, I'm not going to worry about the negative, I'm just going to worry about the number itself, or the absolute value at this point. So 125 is 5 times 25, or 25 times 5. 5 is prime. 25 is 5 times 5. Those are prime. So expanding this problem here, but Okay, well, let's expand it first, then I'll do the but. So expanding this problem here, I have an index of 3, and then I have a 5 times 5 times 5, which is not negative 125. So we're going to do the same trick we did in number 17. We're going to turn all of those 5s into negative. 3 negatives multiplied together make a negative 125. Okay, well, that's only one set. I need 4 sets. So I'm going to have to write negative 5 times negative 5 times negative 5 4 times. Negative 5 times negative 5. One more time. Negative 5 times negative 5 times negative 5. Okay, now my index is 3, so I'm looking for 3 identical numbers. And you can see I have identical negative 5s. I have 1 set, I have 2 sets, I have 3 sets, I have 4 sets of identical negative 5s. So each time I have identical negative 5s, they get moved to the outside of the radical. So on the outside of the radical, I'm going to have a negative 5, another negative 5, a third negative 5, and a fourth negative 5. I multiply all those together, and those all multiply to make 625 positive. I have no leftovers, so that means that is my final solution. So number 19 becomes 625.